All right, example 3, we're going to analyze the graph of a square root function. So remember, we just have a square root function. So yes, there's all these words here, and you hate reading words, but it's really just going to draw. You're just going to have a square root function. Okay, so when blood is donated, medical professionals use a centrifuge to separate it. Centrifuge spins the blood, causing it to separate into 3 components, which are red cells, platelets, and plasma. In order to efficiently separate the blood, the centrifuge must spin at a specified rate, measured in rotations per minute. For the regulated gravitational force, or g-force, exerted on the blood, for a centrifuge with radius, so basically all that can stop. That's just setting up the stage for our equation. For a centrifuge with radius of 7.8, okay, centimeters, the RPM setting of our centrifuge is determined by, so really even the center point, 7.8, we're really not even going to use that. It's just, again, kind of setting the stage of this formula only comes when I have a radius of 7.8. So the RPM setting of centrifuge is determined by the product, so that means multiplication, of 104.23 and the square root of the g-force, right? So it's just really our RPM setting of the future is determined by the product. So if we want the RPM is equal to the product of 104.23 times the square root of the g-force, which I can just use g for g-force. Bam! There's my radical. Done. Now I can analyze it and say what the domain is. I'm not going to have a negative g-force, right? So this got to be 0 or above, g-force of 0 and above, and a range. If I have 0, 0 times anything in front, it's going to be 0, right? So my range is my domain. My range is just going to be, why did I put y right here? It's supposed to be a g, not a y. And then my range, my output, or my RPM, m would be greater than or equal to 0, right? So there you go.